Hey, Math-1. So today we are going to talk about, or in this part 4 of this very long permutation intro series here, we're going to talk about permutation notation, which is going to involve factorial notation. I talked about before, for factorial notation, we do have limitations. We can't do factorial notation for too big of numbers because then once the numbers get too big, your calculator can't calculate them because it's beyond, we get an overflow on our calculator. But that aside, we'll talk about that later on. How do we solve questions that might be like that? Well, they're not on here, but I'm gonna have to. Maybe I'll have to do one on the side and show you how you would do it otherwise. Okay. Yeah. Cool. Now, yeah. So let's look at this first example and talk about this because permutation notation is just kind of like a formula. Remember when we went to our calculator? I went to math. You go over to prob there. What's that for? I've never done that before. Okay, frac. Here we got a NPR. That's the permutation notation. It's kind of a quick way to do the same calculation we've been doing. Right? How permutation notation works is that the first letter. Well, let's look at this one here. This for example. So suppose we have 3 letters. The first letter is how many letters you have. How many choices? How many things do you have? My eyes are really weird here. I'm just going to pause and switch it. All right, that's better. Or is it? Yeah. Kind of weird shiny face. Okay. So the first letter in this P notation, this NPR notation, that's what permutation notation is. Now you might see this written differently in other, I have no idea where everything just went off to there. There you go. They might write that N a little bit higher. They might write it this way instead. Either way, they're both the same. Sometimes they even write the 2 numbers on the same side, N, P, and R. I don't know why they would do that. But the first number, the N, is how many objects you have. So in this case, in this example, I have A, B, C. And I want to rearrange just 2 of those letters. Order matters. You can see all the different ways I can do that. There's like only 6 ways. So you put a 3 down, and then you go P, because order matters, so we've got to use permutation. So 3P, some people say 3-pick, right? Go 3P, and then the next letter over, next number, sorry, would be how many you're actually choosing. We have 3 of them. I want to choose 2 of them. So 3P2, okay? And order matters. So if I plug in my calculator, I should get, let's see, I'm going to go my calculator. Now, if you have one of the newer calculators, this is what happens. You get these little boxes. You just fill them in. If you have an older style calculator, what you're going to do is you're going to go 3 first. Then you're going to go to math. You go over to prob. Go to 2 here. And then you go 2. It's not going to look like this. It's going to look a little bit different, but that's what you have to do. You have to put the number first, then find it. And then, so what it looks like in the older calculators, it goes 3 NPR2. That's what the older calculator does. All right. There's no little boxes to fill in, so you got to do it that way. Okay. Anyway, I hit enter on that. What do I get? Oh, I get 6. Cool. So that's how it works. And you can actually see we could list out all 6 of them: A, B, A, C, B, A, B, C, C, A, and C, B. Now, what is happening here? Now, what is it? What is this calculating? So this, if I just use the fundamental counting principle, I have 2 things. I have 3 for this first one. We got the second one. That's what we have. Okay. Now, if I expand this a little bit more, you think about, okay, where did it go? Like, this is very close to being 3 factorial. It's the same number as 3 factorial, but you notice that when you do 3 factorial, I'm going to just put it over here somewhere. When you do 3 factorial, you get 3 times 2 times 1. Okay. Now, what's missing from here to here, right? Well, this doesn't have that times 1. This has a times 1. So to get rid of the times 1, they would have to divide by 1, right? Well, honestly, it's not going to change this question too much, but by doing that, it's going to reduce this out. So if I go back here now, this is the same if I go 1 factorial, right? Now, where did that 1 come from? Well, that 1 is the difference between the 3 and the 2. I just want to get rid of one thing. I don't want that 1. that extra letter, I don't want it. So I'm just going to get rid of it. Right? So I'm going to get rid of that piece, that one extra piece. Maybe, what if I had more to it? What if I go back to this question back here? I want to take these 6 digits, right? And I want to pick 3 of them. So this would be the same as saying 6p3. Now 6p3, if I go back to the calculator here, no, that's not my calculator, this is my calculator. 6p3, we get 120. So I get the same number this way, so that works, okay? Now, what this is if you think about what's happening here, it's 6 times 5 times 4. And if I continue this on, I have 3 times 2 times 1 as well. But you notice over here, that does this, it doesn't have it over here on the left-hand side. So I need to get rid of those. So this would reduce out. The 3, the 2, and the 1 would reduce out, but that's there. So this is kind of the same as saying 6 factorial divided by 3 factorial. I can double check that. Let's see. 6 factorial divided by 3 factorial. Hey, it's 120 as well. Okay, well, where did that 3 come from? Well, the 3 came from the 3 letters I had left over, right? Not the 3 letters I'm picking, but the 3 letters I had left over. I want to get rid of them. So technically what it comes from 3 factorial, or 6 factorial, sorry. It comes from the 6 that we had originally, minus the 3 that I picked, factorial, which just happened to be 3 again. So it just coincidentally happened to be 3. It's like this one up here. This one has 5 letters. I want to choose 3. Okay, so I can do the same thing with this one here. I can say that this is like 5 factorial. But if I go 5 factorial, that's an extra 2 and a 1. So I need to get rid of those 2 and the 1, which is another 2 factorial. So where did that 2 come from? Well, that 2 came from 5 minus the 3 numbers I picked or kept there, factorial. So that's where this formula comes from. It's n factorial with a total number that we have all the way down to 1, and divide out the pieces I don't want. So n minus r, which will leave me just the pieces I do want, right? Cool. Yeah. So this explains why 5p2 is 20. You can look at this 5p2 is 20. Okay, so 5p2. Okay, so 5p2 is just like I have all 5 letters rearranged in order. And then I want to just get rid of 3 of the numbers because I only want to keep 2 of them. So there's my 2 numbers, which would be just the kind of the same as saying just I had 2 numbers. How many choices do I have for those 2 numbers? And it'll be 20. Yeah. So what does 10p4 represent? So we have 10 numbers. I want to choose 4. Like I could just do this one pretty easily. I can say, okay, I want 4 places, 10 numbers. That's what it is. But what it actually means, I have all my numbers in order, 10 factorial, divided by 10 minus 4 factorial, which is going to get rid of 6 of my numbers. That's what it ends up being. And then you can expand that out. Now I'm going to show you a different way to expand this out. Remember what I was talking about before, like what if you had this and it was like 100 factorial and I chose 20 or something? Maybe I can calculate that, but I can't do it in my calculator because 100 factorial is too big for my calculator. So I can try this and say, okay, I'll put this out here. Math alpha. So what if I ask this question here? Well, this one we'd already know. This ends up being 5,040. I'm going to just throw another question on the side here that could be asked, right? So what if I had 100 P20, right? 100 P20, right? My calculator, I think my calculator can actually calculate that. if I use the P button. But if I try to use the factorial way of doing this question, let's see what happens. I'm going to go alpha window, okay, and then divide by 20, alpha window. I'm probably going to get a Stack Overflow. Yeah, I did. Okay. So let's see if the P button works for this. Oh, quit. I don't want that anymore. Okay, 100, and then I go, what was it again? Oh yeah, I can go alpha window. Yeah, it's right there on number 7, the NPR, and then put 20. Let's see if this can actually do it. It actually does. So it's just enough. So I got 10 to the 30. So how did it calculate that number? It can't calculate 100 factorial. So let's go through the steps of what maybe the calculator did in this situation. So based on the formula, we have 100 factorial, which my calculator can't do. On the bottom, we have 100 minus 20 factorial, right? 100 minus 20, or not even 20 or divide by 20. It's actually divided by 80 factorial until I messed up. It's still giving me an error. I can't do it. Okay, so 100 factorial divided by 80 factorial. Okay, punching my calculator is not going to work. So what the calculator is probably doing is probably simplifying the question before it punches in 100 factorial. And how that works is it does this. It goes 100 times 99. Now I can stop there. 100 times 99 factorial is the same as 100 factorial, because that's what a factorial is. It's 100 times 99 times all the other numbers down to 1. So that's 100 times 99 factorial, which is just all the other numbers down to 1. And I can keep on expanding this out. I can go 100 times 99 times 98 factorial. Okay, so I expand it a little bit more. Okay, that's fine. That's not going to help me too much. But I keep on expanding. I keep on going. 99 times 98 times all the way down to 81 times 80 factorial. I'm going to stop before I go any further there. And the reason I'm going to do that is because 80 factorial divided by 80 factorial reduces out. So what I would have to do to calculate whatever this is without using the P button is to type all of this all the way down to just 81 and stop. Now you could do that. I don't know if that's going to, it's going to be a lot of work. You can go 100 times 99 times 98 times 97 times 81. Okay, so I paused the video, I typed it all out, and hopefully if I hit enter, if I hit enter in the right spot, there we go. Okay, so we get the exact same number, but it was a lot of typing. I got to type it all out, but it's possible, so I can do it. Right, that's all I wanted to show, that you can expand out a factorial and get it to work. But again, you can just use the P button. Now, here's some questions here where we're missing certain pieces. Like here, what's NP2 equals 72, or 12 PR is equal to another number. Okay, so there's two different situations here. I want to find out how many objects would I have to have if I only pick 2 in order matters and the 72 ways to rearrange them. Or the next question is, what if I had 12 objects? How many objects would I have to pick from the 12 objects to end up having 11,880 different permutations? I should have said permutations before, sorry. Now, both of them are pretty tricky questions. What am I going to do to solve this? Well, you can think of this as a factorial. Put this as a factorial notation. Guess you can, for some of these smaller numbers, you can just guess, check, and revise because you do have a limited number, right? Well, let me think. I'm going to just pause the video. I want you to think about that for a second. Okay, so hopefully you tried it out. So the first one here, we can actually do algebraically, okay? So we can write this out in what we call factorial notation. or permutation notation using the formula here. So we got n factorial, which is the first one, divided by n minus r. We know what r is. This r is 2. So n minus 2 factorial has to equal 72. Okay. Doesn't really help us too much, but what we can do is we can do what we did with this 100 factorial. We can expand it out until we can cross off that factorial. And we had no more factorials when we did that. We just 100 all the way down to 81, but there's no factorial. So that's what we're going to do here. We're going to expand out one of the factorials until the factorial cancels out. Now you always, in this case, because the numbers, whenever you expand, always decrease in size, like in that example we did here. It was 100, then 99, then 98, et cetera, et cetera. You always expand out the bigger one to see if I can cross off the smaller. So out of n and n minus 2, n is the bigger one. So this is going to expand to n times n minus 1 factorial. Okay? Those are not the same. N is a number. N minus 1 and n minus 2 are totally different numbers. So that's not going to reduce out. So I'm going to continue expanding. And I'm going to expand one more time. Oh, good. Now we don't know what n is. Hopefully n is not 2. It's probably not going to be 2. We probably tried it. It's not going to work. But this is, in this case, n minus 2, maybe if it was a 5 or something, that would be 3 factorial divided by 3 factorial. Those would be the same number. They're gone. So this would be n times n minus 1 is equal to 72. Now, if you tried to do this algebraically, you probably would have got one answer. If you look at this, there might be 2 answers to this question. We'll have to see, because it's a quadratic. So I've multiplied the n in. I'm going to make this equal to 0 because it's a quadratic. And then in this situation, I'm going to factor it. Let's see what we have. So it might have a negative number. So I do have an extraneous solution in this question. So I only do get one answer. That's fine. What multiplies that to 72? I don't know what I was thinking about there for a second. Nope, not 12 and 6. Those, because I add to negative 1, so I got to think of numbers that are closer to each other. 9 and 8. 9 and 8. It's got to add to a negative number, so the bigger number is going to be the negative here. It's going to multiply to a negative, so that means the other one has to be positive. So my 2 answers I'm going to get are 9 and negative 8. And negative doesn't work because n is a number of things, the number of objects. So this is an extraneous solution. So I really only have one answer. N is equal to 9. And we can double check. NP2. N, or sorry, 9P2. 72. Yeah, it works out. Cool. Verified that it works. Let's check out this next one here. Okay. Now this next one, if I try to do the same thing, a 12 factorial, on the bottom I have n, which is 12 minus r factorial. The problem with this kind of question when you're trying to find r is I can't expand this out because I don't know how big r is. I can go on the top and go 11, 10, 9, 8, but when would I cross it off with r? I don't know, right? Or I can't really go the other way as well. I can't really make it bigger. So I can't really do this question algebraically. So when you're trying to solve for r, really, because you have 12 there, you only have a certain number. You have 12 things. You either pick all 12, pick all 11, 10, 9, 8, all down to 1. So you have a limited number to choose from here. So you're just going to kind of just pick them and just test to see what happens. So this one's just guess check. So you can't really, so I'm just going to write down here, cannot do algebra. Oh, just 1 second. Okay, so like I was saying, for this kind of question, there's only one way to do it. Since you don't know how big r is, there's no way to expand out 12. You have to do this one brute force. No way to do it algebraically. But the cool thing about this kind of question is that you are limited in your numbers. Your R cannot be bigger than 12, because it would make no sense to have 12 things and you pick 13 of them. That doesn't make sense. So you just kind of work your way up. I'll start at 12p0. I don't think 0 actually works. I never tried 0. So I got my calculator here. Nope, 12p0 is 1. So that goes, if you see my answers, I already did this. It's 12p4. But you're just going to work your way up until you get to the number. So in p's, there's only one number. There's only one way to do this number. In combinations, when we do this later on, when order doesn't matter, there's actually technically two ways to do this. And we'll talk about that later. Okay. But right now, you just kind of work your way up. You go n or 12p0, 12p1, which is 12, 12p2. I can't remember what that one is. It's just 12 times 11, 132. Just keep on going until you get to like 12p4 in this case. It escalates pretty quickly, and you get 11,000. So there's your answer. So R is equal to 4. There you go. Cool. All right. So we'll end off this part, and then we'll go to the next part, talk about repetitions. Seems like a lot so far, and hopefully that finishes it off, this intro. Well, there'll be a 5-part intro. Ooh, pretty big. Just the next part is only one video, so that's good. I don't know why I put so much of this first intro. And I'll see you in the next part. See ya.